All right, let's jump right in. Today, we're tackling a really fascinating engineering puzzle. How in the world do you build an AI that can handle one of the most complex, chaotic, and just deeply human environments you can imagine? Yeah, we're talking about Indian roads. And the answer, as you'll see, requires a completely new way of thinking about AI. This sentence right here, it just nails the whole problem, doesn't it? It's not that there are no rules. It's that the systems we build, these neat and tidy systems, are completely disconnected from the messy, negotiated, beautiful chaos of reality. That's the paradox we're going to unpack. So to solve this, we've got to put on our engineering hats. And what's the very first step in any big project? You have to diagnose exactly why the old solutions don't work. You've got to dig in and find the root cause. This is the million-dollar question, isn't it? It's what any engineer or architect on a project like this has to answer before writing a single line of code. Because if you try to force a rigid, rule-based system onto a fluid, constantly adapting environment, well, you're not just going to fail. You could actually make things a whole lot worse. Let's see what that mismatch actually looks like. Okay, so this slide shows the deep, fundamental disconnect. You see, most traffic AI models out there are trained on this neat, orderly data. They assume perfect lanes, all cars looking the same, everyone following the rules to the letter. But the reality on Indian roads, it's more like a complex, beautiful dance. You've got cars, bikes, auto rickshaws, pedestrians, all constantly negotiating for space. People aren't just following rules. They are interpreting them, bending them in real time. A standard AI it can't even begin to process this. And this is the huge mental shift we have to make. We've got to stop thinking about traffic as some kind of machine that we can control. We need to start seeing it for what it truly is, a social system. It's a language of negotiation. And once you see it that way, man, it changes everything about how you'd even think of designing a solution. The moment you see traffic as a human protocol, you have this big aha moment. You realize you've been chasing the completely wrong goal this whole time. The entire objective of the AI system has to be reframed from the ground up. So the old, flawed way of thinking was all about enforcing perfect, rigid compliance, which, is basically impossible. The new human-centric goal is so much smarter. It's about reducing actual risk while working with how people really behave, not trying to fight against it. It's about being an assistant, not a police officer. And this new goal gives us a whole new playbook. It means we need a more advanced, generative AI, one that doesn't just check boxes. It needs to understand context, to see the huge difference between a tiny technical violation and a genuinely dangerous situation. It's got to interpret intent, understand why a driver is swerving, not just that they are. And it absolutely has to be adaptive. It needs to learn from the unexpected instead of just crashing. Okay, so we've got the right goal and we have our guiding principles. So how do you actually build this thing? Let's take a look at the architecture, the blueprint designed specifically to handle this kind of chaos. To understand chaos, you need context, loads of it. The system can't just rely on a video feed. It has to pull in everything. Data from traffic lights, weather reports, even knowing if there's a local festival happening, which, as you can imagine, completely changes the flow of traffic. It also learns from all the historical data from that one specific spot. And here's how that all gets stitched together. First, all those different inputs get processed instantly right there on the device. We call that at the edge, so it can spot events as they happen. Then, that raw data gets layered with all that richer context we just talked about. A GenAI layer then reasons about the whole situation. It's not just asking what's happening, but why is it happening? And finally, a decision engine recommends a human-centric action, something simple like an advisory. Look, if you remember just one thing from this whole architecture, make it this. In any complex human system, context will always beat rigid roles. Having a deep understanding of the why is infinitely more powerful than just knowing the what. That's the whole philosophy right there. Now, that blueprint, it looks really nice and clean on a slide, right? But now we have to step out of the lab and into the messy, complicated reality of implementation. This is where the real engineering begins, navigating the endless gauntlet of real-world surprises. And these are just a few tiny examples. In a simple, rule-based system, every single one of these is a violation. End of story. But in reality, these are normal, everyday, expected behaviors. A human-centric AI has to be designed from the start to understand the nuance here, instead of just freaking out and flagging an error. So how does it handle that nuance? Well, it doesn't just spit out a simple guilty or not guilty. Instead, look at this. It generates a probabilistic risk score. So you can see here it's flagged a pretty high-risk event, 0.72. But it also understands the context. It knows it's peak hour with a ton of mixed traffic. So what's its recommendation? Something proportional. A simple visual warning, and it defers any kind of enforcement. Smart, right? Now, anytime you have a system that learns from data, we absolutely have to talk about fairness and consistency. And I love this quote because it frames the problem perfectly from an engineer's point of view. It treats inconsistencies, what people call bias, not as some vague moral issue, but as a technical debt. It's something that engineers have a direct responsibility to find and to systematically fix.
So how do you actually pay down that debt? Well, with serious, rigorous engineering controls. You have to train the AI on diverse data from all over, not just the big cities. You have to constantly run audits to check for performance gaps in different regions. And you bring in human experts to review the tricky cases, making sure the model is always being fine-tuned to be fair and accurate for its specific location.
Safety isn't an afterthought. It has to be baked right into the architecture as a hard constraint. Look at the split between edge and cloud computing. The design rule here is dead simple and makes perfect sense. Anything where a delay could cause harm, like spotting a risk or hitting an emergency override, has to happen instantly, right there on the edge device. The slower, more complex thinking can happen up in the cloud. This puts safety first, period. And this really gets to the heart of responsible engineering. The goal isn't just to build the most powerful, capable system you can. It's to build a system with limits baked right in. A system that understands when the right move is to not act. It's about encoding restraint as a core feature. And finally, even if you design the most perfect system in the world, you can't just flip a switch and turn it on. To implement something this powerful, you need a really thoughtful, responsible rollout, one that's designed to build public trust right from day one. So you don't go for a big bang launch. The path to getting this adopted is careful and step-by-step. You start small. Pick just one specific risky behavior. Then you model its actual danger, not just whether it breaks a rule. And this is critical. You start with only advisories. No penalties, no tickets. You first prove its value by measuring the reduction in close calls and near misses. And only after you've built that foundation of trust do you even think about gradually introducing enforcement. So what's the big takeaway here? What does human-centric AI really mean in practice? It means you go in expecting chaos. It means you respect ambiguity and nuance. It means your system is designed to assist people, not to override or control them. And maybe most important of all, it means you recognize that safety isn't something you can just import from somewhere else. It has to be designed from the ground up for the specific context where it will live. Ultimately, this whole approach, this entire philosophy, it really boils down to this one powerful idea. If we want to solve complex human problems, we have to build systems that truly understand the people at their core. And that leaves us with a final question to chew on. If this human-first approach can work for something as wild and chaotic as Indian roads, what other complex systems, in our cities, in our economies, maybe even in our communities, could be made better by an AI that learns to assist us instead of trying to override us?